Okay, we're now going to take a look at some examples finding domain, and let's start with this function in part A. Okay, so f of x is equal to 1 over x cubed minus 4x squared. And first, you identify what kind of function it is, right? Clearly, this is a rational function. Again, what's a rational function? Anytime when they have a variable in the denominator, that's called a rational function, okay? So I just went over the 2 steps with you in the previous video, right? Actually, this one, there's 3 steps, depending on how you want to approach this problem. You know that for a fact that you can never ever divide by 0. So you could just say x cubed minus 4x squared is equal to 0. I'm going to start by setting my denominator equal to 0 and then solving for x and then excluding it. Now, if you want to exclude it right in the beginning and say, oh, it can't equal 0 like this, you could do that as well. Okay, so since we did that, let's just roll with it. So over here, how do I solve for x? I'm going to factor out an x squared, and I have an x minus 4 cannot equal to 0. And then I'm going to use my 0 product rule, right? X squared cannot equal to 0, x minus 4 cannot equal to 0. And so when you solve these 2 equations, right, x cannot equal to 0 or x cannot equal to 4. So that's how you would write it in, inequality notation, right? How would you write this in interval notation? You would say minus infinity to 0, union mark 0 to 4, union mark 4 to infinity. Okay, so this is the domain in interval notation. This is the domain in inequality notation. Now, on a quiz or test, I would definitely ask you to specify if I wanted interval notation. So most likely, I would probably ask you interval notation. So make sure you're familiar with interval notation. If you're not quite familiar, go study up on it on the video that I showed you previous to this. All right, so moving on. That was a rational function. And let's take a look at part B over here. Let's say you have something like this. G of x is equal to the square root of negative x minus 5. And you ask yourself, okay, what kind of function is this? You would say it's an even root, right? And for an even root, without spending time graphing it, right, to solve this algebraically, you set the argument, which is whatever's inside the square root or your even root, greater than or equal to 0, right? And then you solve for x. Okay, so over here, you could, add 5 to both sides, but if you add 5 to both sides, you're going to have a negative x. And students often forget to change the inequality symbol when they multiply or divide by negative. So instead of adding 5, I'm just going to add x to both sides. And that is my domain. Okay, so 2 steps, right? You set the argument, greater than or equal to 0, you solve for x, and you're done. How would you write this in interval notation? This represents all values less than or equal to negative 5, right? So if you're not quite sure, right, all values less than or equal to negative 5, close circle, right, x is less than it. This is why I draw a number line. It helps me visualize how do I write this in interval notation. Going from left to right, it would be minus infinity all the way to 5, and it includes the value of 5. There's my domain. Okay, so that's why in the previous video I wrote the number line. It helps you visualize, oh, okay, you want to always go from left to right. Okay, so that's an even root function, right? Set the argument greater than or equal to 0, solve for x. All right, now, these last 2 are going to be a little bit tricky because it requires you to know how to solve a particular inequality, which I briefly went over with you guys in the readiness exam. Okay, so let's take a look at this first example here, and we'll call it P of x is equal to x minus 4 over the square root of, we'll call it x plus 3. Okay, so this kind of function you never studied before, okay? If I were to ask you what kind of function is it, I mean, there's just no words to describe it. I mean, it's a little bit of a rational function, but it's also an even root, right? So when you have a combination of that, you do the exact same procedure as you did with your rational function and your even root. Okay, so we have to do two things, right? The first thing we recognize is that there's an even root, so we're going to set the argument greater than or equal to 0, and we're going to solve for x, right? X is greater than or equal to -3. But you're not done yet, right? You also have to follow the procedure by setting the denominator equal to 0 and solving for x. And then you have to combine these two answers, okay? So x is greater than or equal to -3 is not necessarily correct right now. So the way I solve this equation, right, is I'm going to square both sides. And I'm going to have 0. So over here, right, I'm going to get x is equal to -3, right? But at the very last step, right, I have to exclude it, okay? In fact, you could just exclude it in the beginning if that helps you, okay? Because you can't divide by 0. All right, so how do we combine this answer and this answer? Well, x is greater than or equal to -3, and x cannot equal to -3, right? So if I were to combine these two answers, right, the final answer would just be x is greater than -3, because I have to exclude the value of -3, right? Because if x is equal to -3, you plug it back in here, right? What's going to happen? It's going to make your denominator equal to 0, and you can't divide by 0. So there's your inequality notation answer, and your interval notation would be -3 to positive infinity. Okay, or, okay. Do I have to write both on a quiz or a test? No, you could just write interval notation for me, but I'm practicing, I'm practicing both with you. Okay, so as I mentioned earlier, right, you might have something where you have to solve a, even root function. So let's say I give you q of x, even root function where there's a, where you're required to, where you're required to solve a quadratic inequality, okay? All right, so you already understand the concept, right? This is an even root function. In fact, let's just call this the fourth root, okay? The fourth root of x squared minus 9. Doesn't matter if it's fourth root, sixth root, eighth root. I have to set the argument greater than or equal to 0, okay? Now, this is a quadratic inequality, all right? You can't just get x by itself over here. All right, so the steps I showed you, right, in the readiness exam when I went over it, is you test it on the number line, right? Way 1, test on number line, or way 2, right, which is just to sketch it. Okay, so I'm going to do way 2 because it's easier. And if you forgot how to do it, here's a quick recap. Call this guy your f of x, right? And the first thing you want to do is find your x-intercepts, right? Your x-intercepts, assuming that's f of x, you're going to get x is equal to square root of 9, x squared is equal to 9. You're going to get x is equal to plus or minus 3, right? Those are my x-intercepts. And if I'm going to sketch it and test it on the number line right here, here's -3, here's positive 3. This parabola is going up, right, because a is positive, so roughly it's going to look something like this. Now, going back to this original inequality, this is saying it's asking you, what are the x values such that f of x is greater than or equal to 0? That's what the question is saying, okay? You don't want to get x by itself over here, right? Why did you get x by itself over here? It's because I need to get the x-intercepts. And remember, at -3 and positive 3, right, this time it's going to be closed because there's an equal sign over here. Now, you take a look at your graph, right? Notice to the left of -3, these y values are positive. Between -3 and 3, right, the y value is negative. And then anything greater than 3, the y value is positive, right? And so what was the original question? It says, what are the x values such that f of x is greater than or equal to 0? Well, where's f of x greater than or equal to 0? Over here, right? X is greater than or equal to -3, and x is greater than or equal to 3. So you would say x is less than or equal to -3, or x is greater than or equal to 3. And that is how you solve that particular quadratic inequality, okay? So if you write this on the number line, if you write this in interval notation, right, you would say minus infinity to -3, right? And then union mark, or actually this should be a bracket, right? because it includes the value of 3 for x is less than or equal to negative 3. Union mark 3 to infinity. Okay, so inequality notation or interval notation. So again, if you need some help solving quadratic inequalities, okay, so just take a look at this video again, how I did it. Take a look at your notes that I wrote in the readiness exam for part 1 and 2. Okay, I showed you how to do it. And then way 1, you test it on the number line. Let me just, show you how to do that again on number line, right? Here's negative 3, here's 3. Here's close, here's close. Why is it closed? Because it includes the value, right? Over here you test. Here's x, here's f of x. And if you plug in a number to the left of negative 3, let's say you plug in negative 4 into here, the x squared minus 9 equation, or x squared minus 9 inequality, you're going to get 16 minus 9, which is 7, so that's positive, right? If you plug in 0 over here, 0 squared minus 9, that's negative. And if you plug in 4 into this original inequality, 16 minus 9 is positive 7. I only care about the sign, right? And I'm looking for where f of x is positive. It's right here and right here. In other words, x is greater than 3, or greater than or equal to 3, or x is less than or equal to negative 3, okay? So, which is what I have here in my final solution, okay? All right, so hopefully that is clear. If it's not, you're welcome to ask me in class.